Yes class, good morning. Today topic your problem solving exercise 6.3. Today's second lecture of in this exercise. Today I am taking question number 15 from exercise 6.3. Now what question here? Find the equation of the tangent. You will find here equation of the tangent here. This is the first question in this type question. To the curve. Equation of curve here given, which is parallel this line and perpendicular this line. In this question I am taking both the condition here, parallel condition and perpendicular condition. Now start the solution here. First I am taking the equation of the curve. Equation of the curve. What equation of the curve? Y equal x square minus 2x plus 7. First of all we are finding the slope of the tangent to the curve. What slope of the tangent? dy over dx. dy over dx equal, differentiate here, 2x minus 2. This is the equation first and this is the equation second. Understand this thing. If you differentiate this, then you find here the slope of the tangent to the curve. Means dy over dx of this. Suppose you are differentiating this equation, means this is the equation of the curve. So means slope of the tangent to the curve. Next I am taking here part first here, equation of the line. What equation of the line here? 2x minus y plus 9 equal 0. Y equal, what value is y? 2x plus 9. I am writing this equation in the form of the y equal mx plus c. Comparing y equal mx plus c. I am writing in this form here. To compare it, what value here? M. Now m here 2. Value of the m here 2. Means slope of line m equal 2. Slope of the line m equal 2. But here given condition कि tangent is parallel to this line, but given here, but tangent is parallel. Tangent is parallel to given line. This line. First is tangent is parallel to the given line. Then it means when two lines are parallel, means parallel condition. The slope of the both the lines is equal. Then slope of the tangent to the curve. Then slope of the tangent to the curve is equal slope of the line. Means when parallel both, tangent and line both parallel, means both is slope of the both tangent and line will be equal. The slope of the tangent here this, slope of the line of this. So means 2x minus 2 equal this 2. 2x minus 2 equal this 2. This is the slope of the tangent or this slope of the line. So both will be equal because condition here given is parallel. I am using here parallel condition. So 2x equal 4 and x equal 2. This is the value of the x. Suppose we are putting the value of x in the equation first. From equation first, value of the y. What value of the y here? Equation first here. Square of 2 minus 2 into 2 plus 7. This is the answer only 7 here. So when you putting the value of 2 in equation first, then you are getting the value of y equal to 7. The required passing point. Now required passing point is 27. Yes, not down here. Yes, you notice here, you are finding the equation of the tangent. You know, to find equation of tangent, you have required the passing point and slope of the lines. Slope of the line you have getting here, or passing point you are getting here. Then you can easily find the equation of the tangent. Now, hence required equation of tangent y minus y naught equal f dash x naught x minus x naught. Y naught x naught means xy point here, x1 y1, and f dash x means slope of the line. This is the 2, and y minus y naught means 7, passing point. Slope of the line is 2. X minus x naught means 2. X naught, value of the x naught here 2 means y minus 7 equal 2x minus 4. The 2x minus y minus 4 plus 7 equal 0. The 2x minus y plus 3 equal 0. This is your answer. This is the required equation of the tangent. Remember it. This is the passing point. You are finding at x with help of this equation first, then putting the here, then find the value. This is a required passing point. Hence, required equation of the tangent y minus y naught equal to f dash x naught x minus x naught. X naught y naught here given this passing point, and f dash x naught means slope of the line. Then slope of the line here, putting the value and you getting the answer. Just not first part here complete. Then we will start the second part. First we note down, then start the second part. Yes, students, first part is completed. Now let's start the part perpendicular condition on the line. So now again this is the equation of the curve and slope of the tangent to the same that. We have B part, equation of the line. Equation of the line here in the second line here, 5y minus 15x equal 13. So now comparing y equal mx plus c here. That means 5y equal 15x plus 13, or y equal 5 3 is 15, 3x plus 13 upon 5. You equating here to value of the m here is 3. Means slope of the line m equal to 3. The slope of the line is, but given here, what things given? Tangent and lines are perpendicular. Tangent and lines are perpendicular. It means tangent and tangent to the curve both are perpendicular. So then you can write here m1 into m2 equal to minus 1. This is the perpendicular part. If both are perpendicular, given condition here both are perpendicular condition, using here perpendicular. Perpendicular means line of given lines and the curve equation, tangent to the curve is both perpendicular. So then you using this, the slope of the line already you find here, and slope of the tangent to the curve already given. And equating this is the m1 m2, then putting the value here, 2x minus 2 into 3 equal to minus 1. This is the slope of first, this is the slope of the second, putting here, getting the value of 6x minus 6 equal to minus 1. What will you get here? 6x equal minus 1 plus 6, x equal 5 by 6. This is the value of the, means slope of the, this is the value of the x. This is the value of the x. Similarly, you are putting this value of the x in equation first, from equation first. What value of the y? y equal, this is the equation first, 5/6 square minus 2 5/6 plus 7. You calculate here. 5 5 are 25, 6 6 are 36, 5 2 are 10 upon 6 plus 7. Next, taking LCM here, 36. So 25, 10 6 are 60 plus 36 into 7. 7 6 are 42, carry 4. And 7 3 are 21 and 25, 252. Next, you subtract here 25 minus 12, 2, 15 minus 6, 9, 1, plus sign here 36. Now add it, add here. First I am subtracting this, 2 minus 2 as 15 minus 6, 9 are 2, 1. Then add here 5 up to 7, 9 to 11, 1 1 to 217 upon 36. This is the value of dy. The means required passing point. This is the required passing point here. Value of the x 5/6 and value of the 217 upon 36. This is the required passing point. Where are you getting passing point and slope? You are know slope of the line are given or passing point are given. Then you can easily find out the slope equation of the tangent in perpendicular. Means only this condition you are checking. Parallel condition both are equal or perpendicular. Product of the both the slope is -1. This thing is changed. Everything is otherwise everything is the same. Only condition given condition what parallel condition product slope both the slope is equal or perpendicular condition here both the products slope of the both the product is equal to -1. In this place is changed, otherwise nothing here change. Yes, note down it. Next. Yes, then next here required passing point here. Then we will write here the equation now. Hence required equation of tangent. Required equation of tangent is y minus y naught equal f dash x naught x minus x naught. X naught y naught here given, x naught y naught here given, and slope of the tangent you already find here 1 minus 1/3 minus 1/3 y minus y naught means 217 upon 36. Or this is the minus 1/3 because you already find in this m1 into m2 equal to -1. Value is slope of the tangent. Suppose you are finding this is slope of the line is at 3. This is equal to -1. Then m1 equal to -1/3. In this help you can find the slope of the tangent here. So minus x minus x naught. X naught is 5/6. Then 36y minus 217 upon 36. What else in here? Minus x upon 3 minus 5 upon 18. Multiply inside. And now taking LCM here, 3 6 is the minus 6x plus 5 upon 18. 3 6 is 18. 3 6 is 18 is 6 times multiply here. 36y minus 217 upon 36. 18 to the 36. Then again you calculate here. 36y minus 217 equal, this 2 will be going the right side. तो कितना minus 12x plus 10. When you multiply in the right side, the minus 12x plus 10. So then to write here, transform this side, the 12x plus 36y minus 217 minus 10 equal to 0. So 12x plus 36y and minus 27 equal to this. This is the required equation of the tangent. Very simple. When you calculate very carefully, sign and multiplication and everything you calculate very carefully. Just note down. Then next question. Yes, students. Next question I am taking here. Same exercise, question number 17. This is a very simple question. Find the points on the curve. Given curve here, at which the slope of the tangent is equal to the y coordinate of the point. Question is the simple but different type questions. Sometimes asking in the 2 marks question in this type question. Yes, now start the solution here. First I am writing the equation of the curve. Equation of the curve. What equation of the curve here? Y equal x cube. Then find the slope of the tangent. Slope of the tangent to the curve at any point here xy. Suppose any point here, not point problem. Means dy over dx equal 3x square. Means differentiate of this. Next things are given. At which slope is the tangent is equal to the y coordinate. Slope is equal to the y coordinate given point. Slope of the tangent is equal to y coordinate of the point. Understand these things. Slope of the tangent is equal to y coordinate. Slope of the tangent here 3x square or y coordinate here means y. Similarly 3x square equal to value of the y coordinate here x cube. Remember it. First you write y coordinate means y, or value of the y coordinate here x cube. Then taking the common here 3x square minus x cube equals 0. Understand these things. Taking common here x square, what is left? 3 minus x equal to 0. That means when value of the x here, that means x equal to 0 and x equal to 3. Two value will come here, x equal to 0, x equal to 3. That means putting the value x equal to 0 when x equal to 0, so then y equal to also 0. When x equal to 3, then y equal cube of the 3 means 27. The hence required point is 0, 0 and 327. This is your answer. Very simple things. Question is simple, but you are using the technique of this technique, given techniques. You understand this given technique. A slope of the tangent is equal to y coordinate of this point. Then putting the y or value of the y are already given here. Then using this and finding is the answer. Just note down. Then next question. Yes, students. Next question I am taking here. Question number 21. This is the question. Very important questions. A different type questions here. Yes, question here. Find the equation of the normal to the curve. Equation of curve here given, which is parallel to the line. And equation of the line here given. Yes, you remember that equation of the tangent in perpendicular form and parallel form. This will be has been done. This work is completed. Here in this question you are doing the equation of the normal. This is a different work. Then now start the solution here. First equation of the curve. Equation of the curve here, y equal x cube plus 2x plus 6. First of all, you find the slope of the tangent form. Now, slope of the tangent to the curve at any point xy. You have not any point here. That means dy over dx equal 3x square plus 2. This is the equation first and this is the equation second. Yes, you look this is the tangent slope of the tangent, but you will find a slope of equation of the normal, then you have required this slope of the normal, then converting slope of the normal, then slope of the normal to the curve at any point xy. This slope relation of the slope of tangent reciprocal of the slope of the normal. So this will be minus 1 upon 3x square plus 2. This is the relation of the slope of the tangent and slope of the normal. Reciprocal of this. Then next, after that, equation of the line. Equation of the line. This is the equation of the line here. X plus 14y plus 4 equal to 0. Remember this thing. Always any equation of the line here given. Slope of the tangent, slope of the normal. Yeah, if you find slope of the any equation find, but equation of line here given, then you will convert in the form of y equal mx plus c. In this form, y equal mx plus c. In this form, you will convert here. First, 14y equal minus x minus 4. Y equal minus x upon 14 and minus 4 upon 14. So means slope of the line m equal minus 1 upon 14. So slope of the in this line equal, we are comparing here m and this. M equal value of the m equal to minus 1 upon 14. That means this is slope of the line. Next point. You read the question here, condition given here parallel. This normal is parallel to the line. The given condition here, this is the given. Normal is parallel to the line. Then, if normal is parallel to the line, that means when parallel condition here equal. Now, any two lines parallel, then this will be slope will be equal. Then slope of the normal and slope of the line, this will be equal. Slope of the normal and slope of the line will be equal. But then slope of the normal 3x square plus 2 equal minus 1 upon 14. Minus minus cancel here. What is left? 1 upon 3x square plus 2 equal 1 upon 14. It means 3x square plus 2 equal 14. So 3x square equal to 14 minus 2 equal 12. X square equal to 4 and x equal plus minus 2. Now look here. After solving this, we are getting here value of the x2 value, positive, x equal to plus 2 or x equal to minus 2. So then two values are putting in the equation first, then you will get the two value of the y. Now from equation first, when x equal plus 2, then y equal, putting the value here 2 cube plus 2 into 2 plus 6. 2 to the 4 to the 8, 2 to the 4 plus 6. The value will be getting here 18. When x equal to minus 2, then y equal minus 2, 2 into minus 2 plus 6. So we have minus 8, minus 4 plus 6. What will you are getting you? Minus 6. And last we get the minus 6. It means here 2 points here. Two values of the x and two values of that, means here two normals here. So then required passing point. Required passing point on the curve are 2, 18 and minus 2, minus 6. It means passing point here means two normals here. This two normal means you will find the two equation of the normals here. First passing through this and second passing through this. But slope of the normal always using the minus 1 by 14. Equation of this slope of the normal using this. Slope of the normal, slope of the line, slope of the normal both are equal. You don't use this value, you will use this. Otherwise you are using this, then you are putting the value of x, then calculate them. You directly using this slope of the line equal to slope of the normal. We are writing you then using this slope of the normal. Yes, next you note down. Then next here. Next step here, slope of, first we find the required equation of the normal. Hence, equation of the normal. Y minus y naught equal and here minus 1 upon slope of the normal. The slope of the normal is f dash x naught. Then x minus x naught. Here y minus y naught. Passing point here, passing point I am taking passing point 280 in this passing point. First passing point. So y naught means 18 equal or value of this minus 1 by 14 and x equal x naught means 2. So then cross multiply 14y 18 into 14 equal minus x plus 2. Then transposing here minus x plus x and plus 14y and then multiply here 18 40 72 carry 7 or 18 or 22 25 and minus 2 equal 0. The x plus 14y minus 254 equal to 0. So this is your first equation of the normal. Similarly, hence equation of the normal when passing through this point, slope will be the same here. But then now second equation, y minus when passing point minus 2 minus 6. So then equation y minus y naught here minus 2 minus 6 plus 6 equal minus 1 upon 14 same here, x minus x naught is plus 2. Same here y 14y plus is 96 84 equal minus x plus minus 2. Cross multiply 14y and 46 is 84 minus 1 multiply inside it minus x minus 2. Then we will get your answer here minus x means plus x and plus 14y plus 84 plus 2 equal to 0 means x plus 14y plus 86 equal to 0. This is your second equation of the normal. This is your second equation of the normal. This is the first equation, this is the second equation. In this way you can easily find the equation of the normal. No any problem here, let's note down. Then next question. Then next question I am taking the very important question. This question many times came in the board exam. Here question prove that the curve, two curve we are given, first curve and second curve, cut at the right angles. Here not given, here not right, here the perpendicular condition means, but meaning is the same, right angles and perpendiculars. If this means two curve intersect in position of the condition of the right, you will prove this thing you will prove. Yes, now start the solution here. First equation of the curve. First equation y x equal to y square, this is the equation first. Same equation, next equation here x y equal to k, then you will write k upon x. This is your second equation. After that you will find the intersecting point of the both the curve. So now intersecting point intersecting point of the curves. From equation first and second, we have only first and second. So what value of the x here? Y square. So that means y square into y equal to k. So y cube equal to k, y equal to k exponent 3. This is the value of the y. Value of the y equal to k exponent 1 by 3. This is the 1 by 3. 1 by 3. You putting the value of y here, then find the value of the x from first. From equation first, x equal y. Value of the y equal to 1 by 3 and square. This is equal to k exponent 2 by 3. The intersecting points. Intersecting points here, x, y. Value of the x, k 2 by 3 and value of the k is 1 by 3. After that, this is intersecting point. After that, you find the slope of the first curve, second slope of the second curve at this point also. So now, slope of the curve first. The d here, curve first, x equal y square. Differentiate here means x equal to 1, 2y and dy over dx. Then you can imply that dy over dx equal 1 upon 2y. This is the slope of the, but in this point now slope of the tangent to the curve at point k 2 by 3 and k 1 by 3 point. So then value of here dy over dx. What value of here dx? 1 upon minus 2y. Value of the y is ky 1 by 3. 1 by 3 means 1 upon 2 k 1 by 3. This is the value of the tangent of the curve first. Similarly, here from second, slope of the tangent to the curve second curve here y equal k upon x means k x minus 1. And then dy over dx equal to minus 1 minus k upon x square. After differentiate then you will find the value of differentiate minus 1, then minus sign, and then minus 2, then positive form convert. At point same k 2 3 and k 1 by 3, then dy over dx equal minus k upon x square. X square means k 2 by 3 power 2. Then you can write here k upon k power 4 by 3. After you calculate here, minus 1 upon k 4 by 3 minus 1. So then slope of the second curve at point is equal to minus 1 upon k to power 1 by 3. And this is the from first curve, this is from second curve. Both the curve intersect in the perpendicular, means right angles. Then using the condition of the right angle, then you will be find here both the given condition here. Given here, both curves are intersect at right angles. Then m1 into m2 equal to minus 1. This is the value of the m1, 1 upon minus 2k 1 by 3, and this is the value of the m2 here, minus 1 upon k exponent 1 by 3 is equal to minus 1. Minus 1 minus cancel here, then 1 equal to 2 into k 1 by 3 into k 1 by 3. What value of 2k? Adding the power here, 2 by 3 equal to 1. After that, in this step you very carefully you will solving in this, you have to prove this thing here, then you will be cubic both side here, power cube both side here, the 2k exponent 2 by 3 into 3, power is 3. So here is 1, or here 8 exponent 2. 3 to 3 cancel here, what is left here? 2. So then it means this is proof that. This step very important step. After coming in this step, you will be cubic both sides, then you get this value. Yes, this is a very important questions. Yes, note down.